Circuits allow electrical charges to flow through. The simplest circuit you will encounter in class will have a power source, resistance, and wires. Power sources provide voltage, capital V. The purpose of voltage is to push current through a circuit. The two types of power sources that you are familiar with are batteries and outlets. The units for voltage is volts, capital V. You will also see terminology such as potential, electric potential, potential difference, voltage drop, electromotive force or EMF. These are all terms that are similar to voltage but used in different situations. All circuits need some type of resistance. Without resistance, the circuit will overheat and cause a fire. The purpose of resistance is to prevent the flow of current. The three types of resistance that you will encounter in class will be resistors, light bulbs, and diodes. The unit for resistance is ohm, or the abbreviation omega. For a circuit to work, it needs some sort of current. Current is abbreviated with a capital I. Current is defined as the flow of charge per unit of time. We could write this in an equation format as current is equal to charge over time. If I write it in a symbol format, current is symbolized by I equals to charge, symbol Q, time, symbol little t. There are two types of currents that you are aware of. Direct current, DC, which allows current to flow only in one direction. Example of that is a battery. 2. Alternating current, or AC. It changes direction of the current depending on the frequency. Example of that is the outlet where you plug in your appliances. The units for current is ampere or A or coulombs per second. Because the units for charge is coulombs, the units for time is seconds. Ohm's law relates all three of the variables discussed above. Ohm's law states the resistance is equal to voltage over current, or R is equal to V over I. Or you could write it as V equals IR. Ohm's law states if I graph the current versus the voltage, and I get a linear line, the slope of this line represents 1 over the resistance. When the slope is linear, we say it is ohmic. It tells you that as the current increases, voltage will increase proportionally. If I plot the current versus voltage and I get a curve, this is non-ohmic. Examples of those are a diode. Multimeters are devices to measure voltage, current, and resistance. A voltmeter measures voltage and must be connected in parallel. An ammeter measures current and must be connected in a series. These are some of the basic circuit symbols you will encounter in class. A battery is represented by two parallel plates in which one is shorter than the other. The shorter parallel plate is negative, and it is known as the low potential. The longer plate is positive, and it is known as the high potential. Current always flows from high to low by convention. The battery can be represented by multiple sets of parallel plates. They just have to come in pairs. Resistors are symbolized by the squiggly line. Light bulbs is a circle with a little curl in the middle. A switch is symbolized by two dots. When it's not connected, the bar is up. It is considered open. When the bar is down and is connected through, it is considered closed. So when it's open, current does not flow through. When it's closed, current flows through. Ground is represented by a series of parallel lines that get consecutively smaller. Ground is usually to the earth, which is the largest reservoir of negative charges. A voltmeter is symbolized by a circle and a capital V. An ammeter is symbolized by a circle with a capital A. In the next set of videos, we will discuss the different types of circuits you will encounter in class.